Welcome to TGL Physics. Today we are going to discuss about the properties of equipotential surface. So there are several properties for the equipotential surface. Let us consider the first and foremost property is that no work is done in moving a test charge from one point to another point on a equipotential surface. So here, let us consider here is a surface. Okay. Here is one point A and here is the point B. So the potential at the point B minus of the point A is equal to, I can able to say like this, the work done, that is nothing but a dW divided by what is that? Q naught. I can able to say like this. So here in this particular case, what happens? The VA is equal to the VB. Then both will get cancelled. So what is that about the equation? 0 is equal to, these two get cancelled. Because the VA, the potential of A is equal to the potential of B. So therefore 0 is equal to the dW divided by what is that? Q. Therefore the work done in moving the test charge from one point to another point on a equipotential surface is always equal to 0. So therefore there is no work at all. And let us consider the second point here. The electric field perpendicular to the equipotential surface. So you already know that E into what is that? dl is equal to dw divided by what is that? Q naught. Okay. Just I will say like this, the E into the dl, so just I will write it as what here, the cos theta, okay, that is equal to what here, 0. How it is becomes 0? Then the theta is equal to what happens here? The 90 degrees. Whenever this theta is equal to 90 degrees, so what happens here? The E into the dl, the cos 90 is equal to what happens here? Cos 90 degrees. So therefore it is equal to what here? 0. So when it is happens, it shows that E is, that is electric field, is always what here, perpendicular to what here, surface. So this is the second property of the equipotential surface. You just see this one, the electric field perpendicular to the what here, equipotential surface. This is the second thing. Let us go for the third one. The equipotential surface indicates the strong and also the weak electric field. So let us consider here we have. Now let us consider here is an point A, and here we have over here the point B. The distance between these two is considered as what here? A small distance I am separating is termed as what here? The dr. Now the Q is at any point where I will just mention at the point what here? The O. Point O. Then its electric field is considered as what here? At point A, I will just place one test charge that is considered as what here? The Q or Q plus we can say. Then we already know that how much of the force which is acting on it, the force is equal to force, you already know that. Okay, the force, how much of the force which is acting on this particular point is nothing but what here? Q naught into what is that? Electric field E. Then what is the work done for this? dW is equal to, that is the work done, is always equal to E into electric field into. So this is a small distance from the Q to point A to what here? Point B. So that is nothing but what here? So let us consider here is this is F. Okay. F into what is that? dl. So therefore, what is F here? So dW is equal to F is nothing but what? Q naught into what is that? So I can able to say dr. This can be written in other words. dW, that is the work done, is equal to Q naught into E into dr, that is called a cos theta. When theta is equal to How many degrees? 180 degrees. So what happens here? dW is equal to minus of, okay, u0 into d into what is that? Because the cos 180 degree is equal to what here? Minus 1. Therefore, cos 180 is equal to what here? Minus 1. So you already know that potential difference. What is the potential difference? Potential difference is given by dV is equal to what? The dW divided by what is that? Q0. Substitute this equation to here. So what you will get? That is equal to minus of Q0 into E into dr divided by, so what Q0 is goes? What is dV here? So therefore the potential dV is equal to, just I want to say, what is this? Minus of E into dr. Minus of what is that? E into dr. So what is E here now? Electric field is equal to dV divided by. Okay. So therefore E is proportional to 1 over dr. So this is also termed as the relationship between a what and what here? Electric field and also what is that? Potential. With the help of this, I can able to say that equipotential surface indicates a strong and also what is that? Weak electric field. Please see this one. E is proportional to 1 over the dr. It means that if this distance is very, very smaller and smaller and smaller, and E is becomes a what here? The greater. E, that is nothing but a what here? Electric field is becomes a what here? Greater. So this is how the third property we have, equipotential surface, indicates what here? The strong and also the weak electric field. And the last point, you already know that, this is the well-known point. There is two equipotential surface cannot intersect. Two equipotential surface cannot intersect. It means that, so the 2 points charges is not at all possible. Okay. So these are the 4 properties of what here? Equipotential surface. If you like my video, okay, please subscribe. TG of Physics. Thank you for watching the video.